Good afternoon to all of you. Today we'll be continuing where we left off, Module 12. We will be going with IPv6 addressing, okay? Previously, we studied IPv4 addressing, and most of you have understood the concept and know how to give IPv4 addresses and how to do subnetting. Now today we'll migrate to IPv6 and we'll understand IPv6. So the lesson that we're going to study today is going to look at why do we need IPv6 in the first place, and how do you represent IPv6? What are the address types in IPv6? What is your global unicast address and your link local address in IPv6, and how they are configured, how can you give a static configuration, and how can you give a dynamic configuration for both global unicast address and link local address. We will also look at multicast addressing in IPv6, and we will also look at how do we do subnetting in IPv6, okay? As you agree with me that subnetting in IPv4 is a little bit messy, but when it comes to IPv6, subnetting has been designed inside the address, so it's much more easier. So let's start today's session. We start with, why do we need IPv6 in the first place? Why aren't we just happy with IPv4? Now, most of you have already studied this and know that IPv4 global addresses are being run out, okay? Those 4 billion addresses are not enough. We need more. That is why we had a temporary solution in the form of NAT. But that was also not a permanent solution. So we introduced IPv6, okay? Because IPv4 global addresses is running out, okay? If you look at all these different internet agencies, North America, IPv4 exhaustion date was 2015. Latin America was 2011. Okay, Europe and Middle East was 2012. Asia Pacific region was 2014. Okay, look at Africa somewhere in 2020, this year. Okay, so the issue is that the global public IPv4 addresses cannot be used anymore because there's a duplication of that. So we have to come with a new version. Okay. We have to come with IPv6. If you remember, our IPv4 consists of 32-bit address in 4 octets. But now, with IPv6, we have got 128 bits, okay? Consisting of 8 hextets, okay? Each of these 8 hextets consists of 16 bits, okay? So it's amazing what you can do with IPv6, and with all the projections that industry has come out, we may run out of IPv6 address in the next century, okay? So IPv6 is here to stay. Now, IPv4 is not completely phased out, my dear students. Remember this. In your internet public addresses, yes, we need IPv6, okay? But your IPv4 will still be used, okay? Specifically for your intranet, for your Ethernets, okay? So we haven't completely phased out IPv4. That is why in your case, you have to know both IPv4 as well as IPv6, Okay. So, like I was saying you that IP version 4 and IP version 6 will coexist. That's why when you go to the industry, you have to know both. Okay, that's why your lab exercises will be concentrating on both these skills. Okay. Your Internet Engineering Task Force has created many protocols, okay, to migrate to IP version 6. Some of these are, for example, dual stack, which allows devices to both run on IP version 4 and IP version 6. Like I said, we haven't exactly shifted, so we are somewhere in between. So we have to use both IP version 4 and IP version 6. So dual stack is one way. Tunneling is another way, where your IP version 6 packet can exist on an IP version 4 network. How? It is encapsulated inside an IP version 4 packet. An IP version 6 packet is encapsulated inside IP version 4 packet when you do tunneling. Okay. Now, these are some of the things that you can make, you can command your router to do. Specifically, you will learn this in CCNA-2. And you also have a new NAT, Network Address Translation, which is NAT64, which allows your IP version 6 devices to communicate with IP version 4 devices. Okay. Now, how do we represent IP version 6 address? Okay. Think of it as address representation of IP version 6. If you remember, IP version 4 address representation consists of 4 octets, okay, where each octet was 8 bits. Example, 192.168.1.1. But now from 32, okay, you're migrating to 128. So you have to type more, right? Think about it. That means you have to type a long address, not necessarily. Okay, we're going to learn how we represent the address. First of all, as you know, instead of 32 bits, there are 128 bits. Okay, spread inside this 8 hextets. Each of these is 16 bits. 1, 2, 3, 4, 5, 6, 7, 8. 16 times 8 will give you your 128. Okay? So each hextet is represented by your 4 hexadecimal values, like this. 2001. Okay? So this is your first hextet, second, third, fourth. Generally, this would be a /64 network. A /64 means this would be your network portion. This would be your host portion. If you have a subnet, then you take 16 bits from the network. So this will be your network portion, this will be the subnet, and this will be your host portion. Okay, the host will have 64 bits assigned to it. So maximum number of devices can be given to it. Okay, generally, but you can modify that. You can play around with it. Okay. So this is your example of your IP version 6 address. Okay. Now, the reason it mostly starts with 200, because this is the one which is assigned presently. Okay, and it is enough for the whole world. Now, in future, they may assign other values. When you give your IP version 6 address, there are certain rules you can follow. Okay. Rule number 1, omit all the leading zeros. Get rid of this. Get rid of all the leading zeros. Get rid of the 3 zeros here, 3 zeros here, 3 zeros here. Or if you have got a series of trailing zeros, replace them with a double colon. Let's have a look at this and understand it. Rule number 1, omit leading zeros. Okay. Why do we do these things? So that our IP version 6 address would be shorter. So your 01 AB, okay, hexadecimal value can be represented as 1 AB. You see, just remove the 0. Remove the 0. So the representation can be shorter. Okay. Remember, this only applies to the leading zeros, not the trailing zeros, only the leading zero. So 0200 will be represented as 200. Don't remove the trailing zeros. Okay. The other rule is if you have got a series, okay, of zeros over here, for example, after this we have got 1 1 1 1, then we have got a series of hexstats with 0 0 0. Now you can replace this with a double column. Okay, so this can be represented, you see, after 1 1 1, just put a double column and then 2 0 0. You see, we took this long address and made it short like this. Okay. Now, if you get confused, then you can go ahead and give this address if you want. Okay. But usually, when you practice, if you have got enough practice with IP version 6, we give this format. Okay. The reason we didn't cover this topic last week or the week before is first you have to get your IP version 4 completely clear. You have to understand the concept. Then only we can go to IP version 6. Okay. And last week, after the week free, I found only about 7 or 8 students who submitted their work and they knew what they were doing. So today, I'll be looking forward to the rest to show me their work. Okay. After this. Now, let's look at IP version 6 address types. There are specific address types in IP version 6. IP version 6, since they are new and they have been designed to overtake your IP version, to replace your IP version 4, there is a certain series of complexity inside it, and it solves a lot of our problems. Now, let's look at those address types. We have got 3 kinds of address types in IP version 6: unicast, multicast, and anycast. Okay. Remember, in IP version 6, there is no such thing as a broadcast address. You can simulate a broadcast address by creating an all nodes multicast, which is exactly the same thing. But there is no actual broadcast address per se. You know, in IP version 4, when you want to calculate number of hosts, what do? You calculate the host bits, 2 to the power of host bits minus 2, correct? That minus 2 is because you have to minus 1 for the network portion. 1 for the 0, okay, and 1 for the broadcast address. But there's no such thing as an IP version 6, okay? Usually your first 0000, if you have an address which is 000, that also can be given. That is usually an anycast address. Okay. But you can use right up to the last value in your IP version 6, because there is no such thing as reserving for broadcast. Okay. We also have a unicast address IPv6 unicast, which is it's a global IPv6 enabled address on a device. We also have multicast. It is used to send a single IPv6 packet to multiple devices. And we also have an anycast. Okay. This is actually giving one unicast address to multiple devices. Okay. So the network representation of IPv6 would usually range from 0 to 128. You can play around with that, but usually we say that the network is /64. 64 bits for the network, 64 bits for the host. Okay, so this first 4 octets are for the network, and the last 4 hextets. The last 4 hextets are for the host. So first 4 hextets for the network, and the last 4 hextets for the host. Now imagine the number of hosts that you can add over here. Okay. Now you can modify this. For example, if you want to subnet, so this will be your network bit will be 64, and then 16 bits will be taken, not from the host portion, but from your network portion. 16 bits will be for your subnet. Okay. So how many subnets you can create? 2 to the power of 16. Okay. Now, since IPv6 has been planned properly and it has been designed in such a way that you don't have only a single address, you have 2 unicast address. Isn't that amazing? The first one is a global unicast address. We call it GUA. Okay, this is just like a public IPv4 address, and you can route it and put it as a public address, your GUA, global unicast address. The other one is your link local address. Okay, the link local address is only to communicate within the intranet, okay, within the local link, and they are not routable, they cannot go out. Okay, so we have got a global unicast address. If you see over here, we have got a link local address, just like IPv4 has got a loopback address. We have a loopback address for your IPv6 as well. Okay, so you see, I can just go and open my command prompt. Okay, I can just type ping : 1. You see, because that is my loopback address. This will ensure, I'm going to check and ensure that my TCP/IP is working. Is it working? Yes, it is working. I'm getting a reply. Can you see that? Okay. So this will ensure, this will show, hey, your IPv6 is working on your computer. No issue. Okay, this is the basic test that you can do. Okay. So remember, we have got 2 kinds of IPv6 address: a public global unicast address and a local link local address. Besides that, we also have a unique local address. Okay, let's go through it. A unique local address is like IPv4 private addresses. Okay, they range from this value, this hexadecimal value /7 to this hexadecimal value /7. Okay, here /7 means the network portion is only 7 bits. Okay, and remember your local address over here. Okay, we are talking about this one, unique local address. Okay, this one is used only for local addressing. Okay, and within a certain network of a certain site, if you want enhanced security, then you use this. Okay, and this will also allow you to have that security, and it is not globally routable, so you cannot network from outside cannot access. Okay, so the whole idea is, if you have this on your this private address that you have, just like in IP version 4, we have got private addresses. Here also, you can give this address so that only within one site you can access the network. Others from outside cannot access it. As long as you give this range, remember, it is not routable. It's not globally routable. Now, when you give your global unicast address, at present, only the first 3 bits are distributed. Okay, that's why our IP version 6 addresses always start with 2000. Okay, only the first 3 bits. Okay, and this is only the 1/8 of the total available IP version 6 address space. Okay, and we haven't even filled up these. Okay, so that is why our address right now starts with 200. But then when it comes to our internet service provider, then they can perhaps, remember, the first 3, the 48 bits will be given to us. Okay, the first 3 bits. And then here, 16 bits will be for our subnet. And then whatever follows after that is our host. Okay, there, you see, this would be the 48 bits. Out of the 48 bits, just take the first 3 bits. Okay, that's all we are using right now. Just imagine how much more we have. Okay, and then the 16-bit would be your subnet ID. So how many subnets we can create? 16 bits, 2 to the power of 16. Okay, and here is your hosts, 64 bits. Okay, so how many hosts? You can calculate 2 to the power of 64. No need to do -2. Okay, this is IP version 6. So when you are giving your IP version 6 global routing address, you have got a global routing prefix. Okay, so this prefix usually starts what is given right now, okay, by our ISP, internet service provider. So, okay, you start with 200. Okay, that is if we want to give a static address. Usually we don't do that. Okay, we don't give a static address. The address is given to us by our ISP. So if I go here and type ipconfig and look, my IP version 6 address, okay, have I given this IP version 6 address? No, this address has been given to me by my ISP. Okay, it is automatically configured because they have a DHCP server and it has been automatically configured. Okay, for another computer on my network, perhaps the address will be different. Okay, so this would be, the first would be your global routing prefix. The next would be your subnet ID. Okay, now usually your subnet ID, we take from the network portion, we take 16 bits. So from 64, the network portion will be 48 plus 16 will be reserved for subnet ID. Okay, and the last 64 bits right over here will be given to your interface ID. Okay, so besides the global unicast address, GUA, we also have a link local address, okay, which, as we discussed, enables us to communicate with other IP version 6 devices within the network, okay? Remember, they are not routable, okay? So every IP version 6 address, every IP version 6 device will have either global unicast address or link local address, okay? If you don't have a link local address, it can be configured manually on your interface, okay? And you can give a range for that link local address. So usually this is the range. Your routers, when they communicate with each other, okay, they talk to each other and get each other's link local address. IP version 6, link local address. Your PC communicates with your router's gateway and gets the link local address of that gateway. Okay. Rather than giving your global unicast address, it's advisable to give your LLA. If you don't, it will automatically, if you have got a DHCP server, it will automatically get the LLA of your gateway. And that would be your gateway. Now, how do we give global unicast address and link local address by using our routers or switches or our devices? How do we give IP version 6 address? Not automatically. How do we give a static address? How do we type it? Just like IP version 4. Same way. Okay. If you want to give an IP version 6 address, just like IP version 4, what you do, you go to your interface that you want to give the IP address. Here the interface is Gigabit Ethernet 000. It is a router. And then give your IP version 6 address. Okay. Once you have given your address, there you see IP version 6 address. Okay, so the network portion is 1, 2, 3, 4. Okay, so over here we have got 2 columns because there is a series of 0. So the first device, which is your router 00, will have an address of 1. Next device, 2, 3, 4, 5, and so on. Okay. No shut exit, just like IP version 4. How do I give IP version 6 address to my devices, computers, and devices, my hosts? Just select IP version 6 address, give your IP version 6 address. Okay, prefix is /64, yes, that's it. And then give your default gateway. Here I have assigned my Gigabit Ethernet 00 IP address to 1. So here my default gateway will also be 1. Get the idea, my dear students? Okay. So this is how I can give address to my hosts, to my computers. Okay. You can also give your link local address manually, a static address. Same way, just go to your conft and then type interface Gigabit Ethernet 00. And then instead of giving a global unicast address, you say IP version 6 address. Remember your link local address. If you remember your link local address, this is the range, right? So you have to give exactly that range. Okay. So you say IP version 6 address FE80 colon colon 1 1. So here is your link local address. Usually we don't do this. We don't give manual IP address. Okay, but you can for a small network. Usually we have got our DHCP server, okay, or SLAC. to automatically give IP addresses, okay? But you can give manual address if you want. In fact, in your exam, you'll be tested on this, okay? Let's try this. What we do, yeah. What I do is, yeah, let's take a router. Okay, then what I do is I take a switch as well. Okay, and a PC. Okay, and now I make the connection. Fast Ethernet 0, 2, Fast Ethernet 1, and then Fast Ethernet 2, 2, yeah, 0. Gigabit Ethernet 0. Okay. So what I'm going to do is first let's give that IP version 6 address. Okay, this is a fresh router from the oven. We haven't. Let's go and give it an address. Would you like to enter the initial configuration dialog? No. Okay, so no. Okay, so here I go, enable conf t. Okay, so yes, interface gigabit Ethernet. You know, the short form also, you can try it. Sometimes it may work, sometimes it may not work. 0, 0, 0. Okay, yes, there, that's my interface. Next, what I'm going to do is I'm going to give not an IP version 4 address, okay, but an IP version 6 address. Okay, so remember the command you used to type was IP. Now you cannot do IP, you have to type IPv6. Okay, address, there we go, usually 2001 DB8. If I think I'm making a mistake, let me know. I can't. Okay, and there we go. The first three, okay, hex stats are your 48 bits covered. That means your network portion is covered. Next, you are going to give your subnet. My first subnet is 1. Okay, and then the next portion will be my host, because I'm giving the router global unicast address. So the first one, I want the router to have 1. Okay, /64. Let's check and see whether this works. Yes, it works. So don't forget, just like before, no shut. Done. Okay, exit, exit. Okay, show IP version 6 interface brief. There you can see that I have my address. Okay, this is the address that I have given. Okay, and if you observe, automatically you also have your link local address automatically is given. Okay, now next what I do is I go to my PC and desktop IP configuration. Last time we used to play around with your IP version 6. Now we won't touch it. We'll just go to IP version 6. Okay, you see the link local address is automatically given. So we go to IP version 6. We give a global unicast address, which is just like before, because it's in the same subnet, 2001 colon DBA. Doesn't matter if it's higher case or lower case. Okay, ACAD, Okay, subnet. Next comes the subnet. And next comes your IP address. Let's say 10. Okay, /64. Okay, so once you have done this, okay, you can give your default gateway. Let's not do that now. So we see the consequences later. Yes. So I have given this address. Now what I do is I go to command prompt and I ping my own address. Ping this was the one, right? If I make a mistake, please let me know. ACAD. Here is my subnet 1 and 10. Okay. Yes. You get your standard 4 replies. The connection is perfect. Nothing is lost. Now, what I'm going to do is I'm going to ping my gigabit Ethernet 00, which is in the same subnet. Okay. So what I do is all I have to do is put a 1 and it pings. Okay. So as you can see that your IP version 6 addresses works. Okay. Now moving on from there, let's not leave it at that. Let's play around with it more. What if, no, we can do that later. Okay, we'll leave it here. Now, let's move on to dynamic addressing for IP version 6, global unicast address. As we saw previously, what I did was I gave a static address manually. But usually, a network administrator does not do that. A network administrator configures an automatic IP address, even version 4 or version 6. Okay, so how do we do that? In order to give automatic global unicast address to your devices, okay, you can do something like that by doing through your ICMP protocol version 6. Okay, in fact, ICMP protocol is what we use when you do your ping, my dear students. Okay, this basically, when I say ping, the loop back, when I do this, ping is actually your ICMP echo message. Okay, so similarly, you can find out, get an address automatically by sending an RS, which is router solicitation message, which will be sent by your device. And then the router will send a router advertisement message, okay, which will tell your host how to get an IP version 6 global unicast address. Okay. What should be the network prefix? What should be the gateway address? What is the DNS address? All those information will be given. Okay. So the host will first send the RS, and then the router will send the RA. Okay. In the RA, it can either be a Slack stateless address auto configuration server, or it can be a Slack with DHCP version 6 server, a stateless one, or it can just be a stateful DHCP version 6. Okay. Configuring Slack and DHCP is something you will cover in CCNA 2, not CCNA 1. So let's look at the first method when we use Slack. Okay. So when we use Slack, it will automatically obtain a global unicast address by using ICMP version 6 router advertisement message from the local router. Okay. So this address, of course, it will give us our prefix, including the subnet and so on. Okay. If we don't want that, we will just get the first 48 bits and the subnet we create ourselves. Okay, it depends on us. And then it will also generate a automatic interface ID. Now, the way it generates this is following a random generation number, or it follows EUI64. This one would be tied to your MAC address. We'll study how it works. So you can also have Slack with a stateless DHCP. Okay. The device, your host, will send a router solicitation message. And then the router will send a router advertisement message telling the details, okay, that the Slack is supposed to connect to a DHCP server and solicit a IP address, IP version 6 address. The third method is just using DHCP version 6. Okay, no Slack over here. What you have to do is just like IP version 4 DHCP. Okay, you communicate with your router. Either the router will send a router advertisement message and give you your DHCP version 6. If your router has been configured to be your DHCP device, it will automatically give it to you. If you have got another server as a DHCP server, it will communicate with that, and that will give you your IP version 6 address. Okay. As it says here, a stateful DHCP version 6 server gives you your global unicast address, your also your domain name server address, and so on. Okay. It will also configure your host gateway, which will be configured to the router's automatically linked local address. Okay. Automatically. Here, what I'm trying to tell you is, for example, if I go here and if I want to give my IP configuration my default gateway, I can manually enter the linked local address of my router or put the global unicast address of the router over here as per my default gateway, which will be this interface, which is 000. But if you're using your DHCP, if you click on this, this will automatically be filled out. Okay. Either you have a DHCP server or you have your router configured to act as a DHCP device. Okay. So this one, as I told you, you will learn in your CCNA version 2. Right now, let's ensure that we know our basics, our fundamentals. So the issue is, how does EUI64 process work, and how is it different than randomly generating a value? Okay. So when you use your router advertisement message with Slack or Slack with status DHCP, the client must generate its own interface ID. Okay. In those situations, the client will automatically generate by using EUI64. Okay. So when you use EUI64, it will communicate with your MAC address, and it will use an automatic, it will change that MAC address and create an interface, a host portion for your address. We'll look at that. Or it will randomly generate a value. Okay. Yeah, this is what I was talking about. What it does is, following EUI64 process, if this is your 48-bit MAC, okay, remember your host portion is 64 bits. You cannot just copy your 48-bit MAC address. You have to change this 48-bit into 64-bit. So it will get your MAC address. If this is your MAC address, okay, the 7th bit is reversed from 0 to 1. Okay, so it will add that value. Okay, and it will also insert in the middle of the 48-bit. Okay, in the middle of the 48-bit, it will insert a new value in hexadecimal, which is FFE. There we go. Okay, now you have got a new host address, which is 64 bits. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you have converted your 48-bit MAC address into a 64-bit IP version 6 address. Sorry, IP version 6 address. Okay, so this is how your EUI64 process works. And you can type ipconfig as I showed you earlier, okay, to see what is your IP version 6 global unicast address, what is your link local address, and so on. Okay. If you're using a Windows PC, okay, they usually follow your EUI64. That means they talk to the MAC address, and they generate from the MAC address your IP version 6 address. So dynamic addressing for IP version 6 linked local addresses. So we know how to dynamically assign global unicast address, but what about linked local address? Okay. The linked local address also can follow EUI64 process. Okay. Remember, the linked local address is dynamically created by starting with FE80/10. Network portion is 10. Okay. In Windows, okay, what you have to do is, it's the same method for generating your global unicast address or dynamically assigning your linked local address. Like the previous example, okay, if you look at your IP version 6 address, okay, and your linked local IP version 6 address, you can see the similarity. Okay, can you see the similarity? Why? Because both of them have generated from EUI64. That means this address has come from the MAC address. Okay, the host portion has come from the MAC address. Okay. Your Cisco routers also, okay, follow EUI64. They concentrate on Cisco routers because this is a Cisco unit. I mean, it's a Cisco company, what we are studying, and the academy is under Cisco. So we concentrate on Cisco rather than other routers out there like Huawei and so on. Okay. So your Cisco routers also, they take the MAC address, and from the MAC address, they generate your link local address and your global unicast address dynamically. So if you want to check, you just type show IP version 6 interface brief, as I showed you before. and it will show you your address. Okay. Multicast address for IP version 6. IP version 6 multicast address will have a special prefix, and that prefix consisting of /8. That means 8 bits for network, okay, and 120 bits for the host. So there are two types. One is well-known multicast address and solicited node multicast address. And yeah, this is important. Multicast address can only be for destination. Okay, a series of devices can have the same multicast address, not for source. So you can have either all nodes multicast group, whereby what you do is this: when you have all nodes, a packet is sent to all the hosts in that network. Or you can have all routers multicast group. Instead of N devices over here, it will send to all the unicast, global unicast routers in the network. Okay. You can also have a solicited node IP version 6 multicast, okay, whereby based on what you send, the host will check, okay? So a solicited node multicast address is mapped to a special Ethernet multicast address. And then the NIC can filter and check, okay, and see whether it is destined. For example, this will say, no, this is not for me. This is not for me. Yes, this is for me. Okay. So it can check by examining the MAC address and see it is destined for which one. Finally, if you remember when we studied IP version 4, the concept of subnetting was a little bit tricky, but hopefully most of you have understood it and can implement it. Now, in IP version 6, subnetting is so straightforward, okay? Like I said, from the network portion, take 16 bits. So now your host portion is 48 bits. That means the first 3 hextets is for the network portion. And then 1 hextet is your subnet ID. Okay? And you don't touch your host portion. Your host portion, you leave it as 64 bits. Okay? That's why they say IP version 6 was designed with subnetting in mind. Okay? So, if you want to create, for example, here, you see, the network portion is the first 3 hextets. The subnet is your 1 hextet, 16 bits. Starts with 00, 1, 2, 3, 4, 5, 6, 7, and so on. How many subnets you can create? 16 bits. So 2 to the power of 16. That will be 65,536 subnets. Okay, that's why subnetting over here is much more easier. Now, look at this, for example. What we are doing is we have got there gigabit Ethernet 00. The subnet we have given is 1. Here, for 01, we give the subnet as 2. For another network, we give the subnet as 4, 5, and so on. Okay? And you can check. You can give your IP address based on different interfaces. Like in the packet tracer, if you observed a few minutes ago, I gave an IP address on this subnet. Now, I can go and create another one on another interface, on interface 001. I can give subnet 2 or subnet 3 as shown over here. Okay, there's no here. Subnet 3 is between router to router. So the question is, how many subnets do we have over here? 1, 2, 3, 4, router to router, 5. Okay, so 5 subnets allocated. Okay, so let's try this. Okay, so what I do is just the same thing. I go and, create another network here with another PC. Okay, now if you observe, this network is a pure IP version 6 network. Okay, there's no dual IP addresses over here. It's just IP version 6. I haven't given any IP version 4 address. Okay, so going back here, enable conf t. Okay, now remember, I have already given a IP version 6 global unicast address for interface 000. Now let's give for interface 001. Okay, another address. But remember, this is going to be on another subnet. If this one is 1, I'm going to give a subnet 2 over here. Okay, so interface, right? /0/0/1. Yes, I'm in. Okay, now that I'm in, I'm going to give IP address, IP version 6. Okay, you cannot type this IP address. If you type this, that means IP version 4. You have to say IP version 6. Okay, same like before, 2001 DB8 ACAD. Okay, now comes my second subnet, not 1 but 2. Okay, and my router interface 001, I want to start with 1 as well. Okay, /64. Okay, that's it. Done. No shut. Okay, exit, exit. Show IP version 6 interface brief. There we have. This was the address for 000 interface I had given before. And this is my 001 address I've given. The subnet over here is 1. The subnet over here is 2. Okay. As you can see, again, for interface 001, the link local address is automatically given. And how is it given? By looking at your MAC address, okay, and adding 16 bits to that, making your 48-bit MAC address into 64-bit host address. Now, let's see whether let's give an IP address over here again, IP version 6, which is going to be same thing, 2001 DB8. Remember, not case sensitive, ACAD. Here, remember, we are on subnet 2, okay? And let's say 10. No, in order to 10 would work, but in order to remove confusion, I say 11. Okay, /64. Okay, there, done. Okay, so sorry, open it, go to command prompt, ping 2001 BBA ACAD subnet 2, ping myself, and the network is getting your reply. Now, ping to interface 001, and it works. Okay, now let's ping to the other side of the interface, that is 00. Definitely it will not work because I have not given my gateway address. So when I ping, request timeout, okay? There, it cannot find it because you have not, we have not configured our gateway, okay? So there, all the 4 packets are lost, 100% lost, okay? So how do we fix it? What I do is I go to my, what I do is I give my default gateway, okay? My default gateway is 1, correct? Save. Okay, here also, what I do is I give a default gateway. Remember, default gateway address, I'm giving my global unicast address, which is 1. Okay. Now, again, let's ping. Okay. So you can ping to your side of your router, which is 01 interface. No worries. What about the other side, which previously we could not? Let's check and see. Yes. Now we can ping the other side as well. Okay. Same goes for this. Ping the other side. No, that's pinging your own side. Yes. Now ping 001, which is 2 subnet, and it works. Okay. Now what I'm going to do, since I can ping from here to this side,
the question is
here. Yes.
If I use the link local address in one site and as a gateway for 01, so can it? I mean, it will work.
Yes, yes, you can give a link local address as well as a gateway. But usually when we give a static address, we give a global unicast address.
I see. But I have another question about the subnet ID. Like, we actually use the subnet ID for IP version 4 because of limitations, right?
Yes, yes.
So for IP version 6, we have thousands. I mean, we cannot count the number. Okay, so
yes,
why we use subnet ID for IP version 6?
But it's the same rules. In the same rules, when you create a subnet, you make your network fast. You agree, right?
Yeah, exactly.
So that is why in IP version 6 also you do the same thing.
Okay, thank you.
Yeah. Thanks. Now I haven't finished. What I did was from PC0, I pinged my own interface gateway and the other gateway which worked, okay? And from PC1, its own interface and the outside, the gateway, it worked. Now, what about from PC to PC? Let's try this. Okay, you'll be surprised. So what I do is I ping to 2. Remember the IP address of PC1 is 11, correct? Does it work? Check. It does not work. Okay. Now you'll be asking, how can it not work when you can go to the other side of the router? Why can't you go to PC1? Okay, there's a reason. Let's do the same thing over here. Okay, let's do the same thing over here. Ping from here to PC0. Okay, remember PC0 is 10. See, cannot. Okay, it doesn't work because you have to enable your router to be IP version 6 routable, unicast routable. Okay, that is why it doesn't work. You see, 100% loss. Until you don't do that, it won't work. So what I do is I go over here again. Okay, so I type conf conf t. Okay, so now that I'm here, then I just type IP version 6 unicast. Hope I don't unicast. Yeah, router or routing. Let's check routing. Okay, and yes, it works. Good. Exit. Okay. So once I type IP version 6 unicast routing, that means it will allow the pings to work. Now let's try again. The same command like before. I'm pinging from 0 to 1. Does it work? Yes. Now you see it's working. Let's do the same thing from here. Okay. Ping from PC1 to PC0. After you have enabled unicast routing, IP version 6 unicast routing. Okay. So ping, yes, it works. Okay. So this is how it is done, my dear students. Okay. You can create a network. As you can see here, I've created a network without IP version 4. And all of these devices that I have, they have got a global unicast address. Okay. And all have been given manually. It's a static address. And they can communicate with each other. This is one subnet. This is another subnet. And you can agree with me that subnetting, when it comes to IP version 6, is very straightforward and very easy. Okay. That brings us to the end of this session, IP version 6. Another important thing you have to know for your exam. Anyone has any questions?
Can you go up the slide? Just one slide up.
This one?
Yeah.
Yes.
Serial over here. Interface serial 0/1/0. What is serial?
This one.
Yeah. No. Go down. No. The one you already swept.
Yes, I know. This
Yeah.
one. Serial means this.
Yeah.
Get it?
Oh, go. Yeah. Got it.
Yes. Okay. Router to router communication. You will study more about it in your CCNA-2. Because when you communicate between router to router, you can have a serial connection. If you look at your, this one, see? This is your serial connection.
Oh, okay. Thank you so much.
Thanks. Anyone else has any questions? Okay.